correct the work that you have done. Okay. Again, it's important that when I hand it over to you that you at least try. Let's say you're stuck on a few, that's understandable, but you still have to give it a try. Okay. All right. So we have a table here of blood types. Okay. That were donated in a recent drive. So this is, if you think about, right, if you think about the number of people in total, let's add it up, right? This, if you add all of these up, which is usually a good idea when you're doing probability anyways, we get 850 total. Okay, if you add it all up. So that's a decent sample size. It's not huge, but it's decent, right? What would you say if I look at this table in theory, theoretical probability? What's your theoretical probability of having A positive in theory? Well, you'd have to say, well, there's one A positive here. So 1 out of 1, 2, 3, 4, 5, 6, 7, 8. 1 out of 8, right? In theory, you have 8 blood types and you can have one of them. Does that translate to normal, everyday, like normal population? The 1 out of 8? Would you say that 1 in 8 would have A positive? It's not true, right? So this is an example where theoretical does not match experimental. You have to go by experimental because what actually happens out in society is that most people, right, have O positive or A positive, right? Most people do. And that's a fact. You can't change that. You can't say, well, no, let's just draw more blood from more people, right? And then maybe we will get closer to the theoretical probability, which is 1 in 8. Not going to happen, right? It's not going to happen. This number is just going to increase more and more. You're going to realize that there are more people with O positive, A positive than all the other types. So these numbers are experimental, right? And we'll say what actually happens, right? So all of these probabilities that you've calculated, if you did them, those were all experimental because it's based on you actually collecting samples. You just need to understand that because we're going to kind of go between the two, okay? So let me just see if I can focus. Okay. What is the probability that a person selected at random, that always needs to be said, or if it's not said, you can assume that, has the following blood type? So B positive. So probability, let me just go back and use all the space here. Probability of B positive would be 77. There are 77 samples collected out of a total of 850. Right? And okay, if you try to simplify, good on you, but you can't. This gets you 0.0906. If you divide these two and you round to 4 decimals, that's what you get. Okay, so you could choose. This is the nice little trick here. If I don't specifically ask your answer to be as a fraction, you can choose to state it as a decimal or percent or whatever. But if you state it as a fraction, if that's your final answer, it needs to be simplified. But in this case, it doesn't tell you which format to use. So I would always say, hey, just go decimal and then you're guaranteed not to have marks deducted. Okay? And that also translates to, I'm just going to put commas, okay? I like that more. Comma, this, comma, 9.06%. So you can choose to write it in any one of those three formats. Okay. What about just O? It's just saying O. So that's it's basically saying it could be positive or negative. That's what it's saying if it's just O, right? So probability of O, of blood type O, is 327. Remember, or in math represents adding, right? You're drawing a purple marble or a red marble, right? You're adding them up. So this is 327 and this is 69. So we put that down. Over, it's still 850 total, right? And that gives you 396 over 850. You can tell that they're both even. So we're not going to simplify. I instead just going to go like this. And I don't have the decimal here, so I'm going to go. It can be simplified. This is 0.4659 if you round it, because it's 588. Okay, so the fourth rounds to a, which is in turn 46.59%. Just multiply that by 100 to get the percentage. AB negative, that's specific now. AB negative, there's 1 out of 850. Can't simplify that any further. That gives you, if you divide, right, 1 divided by 850, that's 0.0012. Very, very small percentage. And if you multiply that by 100, this multiplied by 100 is 0.12%. So if you have that blood type, it's going to be really hard for you to get. And all of these are experimental probabilities. If I asked you for B positive in theory it would be 1 out of 8, right? And just to give you a reference, 1 divided by 8, right? That's 12.5%, which is not going to match this, right? So you got to understand that. Okay? So let's go down here. If data is approximately represent the blood type distribution of the general population, so if what we collected here is true in general, if the spread is true in general, how many people in a group of 5,000 are likely to have blood type AB positive? So you're making a prediction. Right? You're making a prediction based on past experiences or probability, or yeah, something that you have collected on a smaller scale. Now you're going to apply that to a larger scale. Okay, so probability, sorry, what did I give you? I'm just going to check for the prediction. Prediction, okay, there we go. I did that. So I'm going to say prediction would be probability of AB positive, sorry, multiplied by 5,000. So probability of AB positive would be 27 over 850. That's straight from the chart, right? 27 over 850. That's the probability. You don't need to simplify it ever when you're doing a question like this. Times 5,000. And you get 158.82, which is roughly, we'll round it up, 159 people with AB positive blood type. So you round it to the nearest whole number to be safe. So applying, right, this is going general population. And I gave you another method, which is, involves proportions. You can use that if you want, no problem. Another similar situation here. Right? Okay. Rianne polled students in English 12, right, classes in her school to find out the types of book you prefer to read. Again, you polled students, right? That right there should tell you that this is going to be experimental, right? That tells you it's experimental. Okay? And then there are the different genres, right? And the people that prefer each genre. Now, in theory, right? What are the chances that Mr. Dirksen likes action types of books, right? In the genre of action. Well, it's 1 2 3 4 5 6 1 in 6, right? In theory. And so you would just say, well, case closed, right? 1 in 6 people will like action. Let's not poll. Obviously, you know that that's not true. That's why polling exists, right? They want to know, what do you prefer? What is your preference, right? Different flavors of ice cream, right? Oh, it's like 1 in whatever flavor, however many flavors you're offering, that's the chances of somebody picking it. Well, no, it's not true, because certain things there's a preference, there's a bias towards, right? So we have this many, we collected data and we get a total here. And the total is, I'm going to put it down here, is 104 students. Okay, there's 104 students that we've collected this info from, because it's probability, you're going to need to know your total. There's a probability that a randomly chosen student will like poetry book. Probability of poetry, right, is going to be 5 out of 104, which in turn is 0.0481, which is 4.81%. Okay. They could ask for anything, for action, science fiction, you name it. You do the same thing. You grab the, I think the definition said desired outcomes. It's the desired outcomes, which is, right, poetry, there are 5 of them, over total number of outcomes, right? What is the probability that a randomly chosen student will like historical novels? We'll just do that. And there are 4 out of 104. This one is pretty easy to simplify, right? 4 goes into both of them. Let's just do that. That'd be 1. This would be 2, 26. 1 out of 26, simplified. And that gives you 0.0385 or 3.85%. You choose one. You don't have to do them all the time, right? All 3. When I ask you a question on a test or a quiz, you choose which one and just stick with it. You don't have to do all 3. All right, let's see. There's probably going to be a prediction after this, right? So let's go. There's a C at the back here. If the school is adding to the library and has a funding to purchase 1,000 books, how many should be science fiction? Right? Prediction. Right? You're making a prediction here. So we will say prediction is probability of sci-fi, right, times the 1,000 books that we're buying. And what's the probability of science fiction? I have my other book here. So there are 28 out of 104, right, that are science fiction. That's a probability of science fiction times 1,000. And that gives you 269.23, which is approximately 269 books. Science fiction books. Okay. So remember, when it's most likely it's going to be a whole number because we're dealing with discrete data, right? And so we'll deal with that. Okay, so new skills working with sample size. I'm not gonna really talk about that yet, so I'm gonna skip that part. But basically, what they're gonna say here is, unless you have a large enough sample size, your polling results will be biased. Okay. So, for example, there's a bunch of things happening here, but let's say you just ask people on Twitter or on Instagram or on Facebook, right? You poll those people. Is it going to be biased if you're not making phone calls? Like, who still does phone calls, right? I hope nobody's offended by this, but older people still answer the phone, right? Like they would, if you get a phone call, 1-800 or whatever, you don't recognize the number, do you pick up? I don't pick up, right? I just can't, I just decline, right? So if you're only, like if your sample size isn't diverse, right? It has to be diverse. You have to have different mediums. If you just go to the mall to poll people, it's also not going to be accurate, right? Because if you go to a Tim Hortons at like 6, 7 in the morning, and you go to the mall, and you make some phone calls, and you go Instagram, and then you collect your data, that'll be a pretty diverse, accurate representation of what's happening in real life. So they're going to talk about sample size having to be diverse, right? Diverse and large size. Right? Those are the two things that you want to, like the size of the sample has to be larger and diverse for you to have an accurate result. Right? And that's like, again, I don't know if you follow the elections, right? The polling industry is almost, they're not able to get that right. They're having a hard time accurately determining what's going to happen during the election or after the election, right? Okay, so we are going to, I'm going to do a little pop quiz here. No, not now. We're just waking up. So I'm going to stop this record.